to Mathematics Alive. Our topic for today is the beauty of codes. Can we talk about beauty in mathematics? The answer is a resounding yes. And our topic for today will prove that. Codes are already around us since the time of our ancestors. A code is a symbolic way to represent information. Below is an example of a message hidden in codes in the form of a riddle. I stand alone before 50 in Rome. None came before 5, the 3 inverted, and you will be the last. What is the meaning of the riddle? The answer is, I love you. I stand alone before 50 in Rome. So 50 is the symbol L in Roman numerals. None came before 5, so that is the 0. And then the 5 is another Roman numeral. And then the 3 inverted, that's a Greek letter epsilon, which stands for E. And you will be the last. I love you. Hieroglyphic numeral system. During the ancient times, hieroglyphics, or sacred writings, were used by the Egyptians in their writing system. These are examples of the codes representing hieroglyphic numbers. So we have the number 1, which is used for writing 1 to 9. You just collect 9 sticks, and then you have the number 9. And then you move on to the number 10, which is an inverted U, and the number 100, which is a coil, and 1000 is a symbol for tulip flower, and then 10,000 is a bent finger. 100,000 is a frog, and 1,000,000 is a man in that position. And below is an example of a hieroglyphic number, 258,458. So if you write this in hieroglyphic numbers, you can see the whole length of the drawings that you have to make, and you have to be good in drawing. Here are some other examples. 3,244. We have 3 tulip flowers. 200 is represented by 2 coiled string, and then 44. So you have 4 and 4 sticks. 21,237. So we have 20,000, 1,000, 200, 30, and 7. It's very easy to write in hieroglyphics, but do you like to do your computations using these numbers? Of course not. Traditional Chinese numeral system. I'm just giving you an example of how the Chinese coded their numbers, but since it's very hard to write in Chinese numerals, we will not force you to memorize all this. And here is the more familiar Roman numerals. We have the Roman numeral table from 1 to 1,900. So since we are familiar with that, we use that in outlining, but of course we don't use Roman numerals in computations. We'll just review a little. So to write 1 to 3, we just have to use the sticks, 3 sticks for 3. And then for 4, we use the symbol 1 and V. So for number 5, we have the V, but for number 4, we have V minus 1 or 5 minus 1. We just subtract the Roman numeral 1 if it is written to the left of the number or to the left of the symbol. So if it is written to the right, like the number 6, 5 plus 1. So you add when you are writing a symbol which is lower than the symbol to the left. Example, we have the number 40. So the symbol for 50 is L and the symbol for 10 is X. So this is 50 minus 10, 40. And the number 70. So we have 50 plus 10 plus 10. And we have the number 500 and before this 400. So this is 500 minus 100. And for 900, you have 1000 minus 100. And for 1900, you have 1000, this is the M, and then the CM stands for the 900. So M minus 100 is 900. Okay, to complete your review of Roman numerals, here is a Roman numeral chart from 1 to 100. Now let's go to a less familiar but very important number system, which is the binary number system. A binary system is a number system that uses only two values, 1 and 0, which stands for on or off, to represent codes and data. Since zeros are and ones are easily represented by two voltages, the binary system is the foundation on which digital technology is built. How do we convert from binary to decimal system? Okay. The number in green color is representing a binary number. So this is in base 2 because you have only 2 digits. And then the rightmost place value is equal to 1 times 2 to the 0 or simply 1. The second one, the second place value is 2 to the first, 2 to the second, 2 to the third power, and so on, up to 2 to the 7 in this number. So all of these place values represent numbers here which are to be added together to get the number in our decimal system. So we have 1 plus 8 plus 16 plus 64 plus 128 is equal to 217. So this number is simply 217. Let's take another example. The number 110110111. Okay, and we will convert that from binary to decimal. So we'll start with the rightmost number, which is 1. Then we will move to the left. So we will assign all the values from the rightmost number to the leftmost number. And these are the values. So we have 1, 2, plus 8, plus 16, plus 64, plus 128. And our decimal number is equal to 219 base 10. Okay. And we came from 1101111 base 2. Okay. We indicate the base for this number so that we will not be confused whether this is a decimal number or not. Another way to convert binary to decimal is to make a table like this. So you have a table of place values from the rightmost to the 0 to any power of 2. And then you just place the number in column with the place value that it represents. And then you can get the actual value and add those values. So this number 1011001 base 2 is equal to 89. Now, how do we convert from decimal to binary? Example, 156 or 156 base 10, and we will convert that to base 2. First, we divide the number 156 by 2 and indicate the remainder on the right, as in the illustration below. So we have 156 divided by 2, and then there is no remainder. So you get 78 and continue the division until you get a number which is no longer divisible by 2, or you have a 0 remainder. So repeat these steps until the number is no longer divisible by 2, and reading upward, the answer is 1001100 base 2. That is your binary number from 156 base 10. Okay, here are two more examples. 25 base 10 to binary. So we divide 25 and the answer is 12. 25 divided by 2 is 12, but you have a remainder 1. 12 divided by 2 is 6. You have no remainder, so that's 0. 6 divided by 2 is 3. Again, you have no remainder, 0. And 3 divided by 2 is 1, and you have a remainder 1. And 1 divided by 2 is 0. So the 1 here becomes the remainder. So this is the fifth remainder, but you read upward, and the answer is 11001 base 2. Number 2, we have 47 base 10 to binary. So this is another way of dividing. 47 divided by 2 is 23, and you have a remainder 1. 23 divided by 2 is 11, remainder 1. 11 divided by 2 is 5, remainder 1. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 1, remainder 0. And 1 divided by 2 is 0, remainder 1. And then you read upward. So 47 base 10 is equal to 10, or 10111 base 2. Now let's move on to barcodes. These are familiar. You can see barcodes in your favorite food stuff, in your junk food, and in almost anything that we buy in stores. A barcode is an optical machine-readable representation of data. Traditional barcodes systematically represent data by varying the widths and spacings of parallel lines and may be referred to as linear or one-dimensional barcodes. Later, two-dimensional or 2D barcodes variants were developed using rectangles, dots, hexagons, and other geometric patterns called matrix codes or 2D barcodes. How do we use barcodes? It is used for automated data collection in businesses. It eliminates the occurrence of human error since through the use of a bar scanner, transmitting data is fast and reliable and takes lesser time than entering them manually. Here are some types of two-dimensional or 2D barcodes. We have the Aztec type, the Maxi code, the quick response type. Identification numbers are also codes. Identification numbers are used to identify individual items, specific products, and even people, accounts, or documents. Examples: numeric identification number like TIN or tax identification number. In tax identification number, we only have all numbers. And school ID. A student is assigned his number in a school when he enrolls. And then bank account. We have numbers assigned to us for our bank account. Number 2, alphanumeric identification number. Examples of this are vehicle plates and passwords in our computers. Here are some examples of car plate numbers. We have 3 letters and 4 numbers or 3 numbers. It depends on the vehicle that it represents. Universal Product Code or UPC. Universal Product Code is a 12-digit identification number of a retail item. Nearly every item that we purchase from the supermarket and department store has a UPC on it. These barcodes were originally created to help grocery and department stores speed up the checkout process and keep track of the inventory. It used to be manually recorded in small department stores or even in small grocery stores, but now we have a modern technique which is very helpful for our department stores and groceries. 12-digit UPC. In a 12-digit UPC or Universal Product Code, digit 1 indicates the specific use of the product. So we have the following numbers to represent the specific use. 0 is used for general groceries. 2 is used for meat products. 3 is used for drug and health products. 4 is for non-food items. 5 is for coupons, and 6 and 7 are for other items. The other numbers are reserved for future use. Digits 2 up to 6 identifies the manufacturer. So the manufacturers are coded. Digit 7 up to 11 identifies the product. And digit 12 serves as the check digit. The check digit, D12, is added so that it follows the formula here. 3 times digit 1 plus digit 2 plus 3 times digit 3 plus digit 4 plus 3 times digit 5 plus digit 6 plus 3 times digit 7 plus digit 8 and so on up to digit 12 is divisible by 10. Examples. The UPC 0-53600-10054-0 is valid since if we apply the formula for the check digit, the sum of this will be divisible by 10. The sum is 40 and it is divisible by 10. You can check it out. Number 2. Find the check digit of the UPC represented by 7-70832-30854 X. So the check digit is unknown. So to solve for X, we follow the formula where the first digit and all the odd numbered digits are multiplied by 3. And then the rest of the digits are added. And the result is 97. So you think of a number X, which when you add to 97 will give you a number divisible by 3. And it should be the next higher number to 97. And thus we add 3, which is the smallest positive integer, less than 10, so that the sum becomes 100, which is divisible by 10. Hence, 97 plus x is equal to 100, and therefore, x is equal to 3. Number 3, the UPC of Kellogg's Corn Flakes cereal, 24 ounce, is 03800001277. Using the UPC check digit formula, check if the UPC is valid. Again, you should learn by doing. Do it yourself. International Article Number, EAN 13. The International Article Number, also known as the European Article Number or EAN, is a numbering system used in global trade to identify a specific retail product in specific packaging configuration from a specific manufacturer. EAN 13 format barcodes have been used throughout the rest of the world, while UPC 12 is used in the USA. The first 3 digits of EAN 13 represents the country code. The country code of the Philippines is 480. So if you look at the product and you want to find out if it is imported or not, you look at the first 3 numbers in the EAN code. 480 is from the Philippines. The check digit formula for EAN 13. Given a 12-digit string, D1 up to D12, the check digit is D13. And so the formula is different from the check digit of UPC. We multiply every even digit or every even number digit like D2, D4, D6, D8, D10, and D12. Multiply it by 3 and then get the sum of all the digits and be sure it is divisible by 10. Example. Show that the EAN 13 barcode of the following Philippine-made products are valid using the EAN check digit formula. Number 1, Goldilocks Pinoy Deli Line. So you see here 4800111009901. And if we apply the formula, we multiply the even number digits by 3. And then we add all the digits, and the answer here is 70, which is divisible by 10. Therefore, the EAN barcode for this product is valid. Letter B. Dr. J, 70% solution ethyl alcohol, 500 ml. Again, we start with 480. So this is a Philippine-made product. 9012648165. And you have to try the formula. to check if it is valid. You will do that with the next product, Mr. Chip's Nacho Cheese Flavor, 100 grams. Try these 2 items and remember, you learn by doing. Try checking on the barcodes of your favorite products and apply the check digit formula for your practice. After this lesson, try to discover the beauty of codes all around you. I hope this lesson had been an eye-opener to the wonderful world of codes. Please like it, share it, and subscribe to this channel by clicking the red button below. Thanks for watching and bye-bye.